So today we'll be starting with the another lecture which will be in the Panda series, and this in this lecture we'll be learning about the descriptive statistics and basic analytics in Pandas. Okay. So uh, by the end of this session, we'll be learning about like the description what are the descriptive statistics are and how to use Pandas to like calculate and get the insights using the stats and how to perform the correlation analysis, which is basically means like what is the relationship between the two columns that we will be need to calculate the insights, and how to interpret these results and how to apply these analytics in real data sets. Okay, so let's get started. And first of all, we start with what is descriptive statistics. Okay, so descriptive statistics is used to summarize and describe the main features of a data set. Okay, so it includes three things like central tendency, mean, median, mode, which means like uh, we represent data from using a single value. Okay, uh, in the real version when you learn about like what is mean. So we used to describe take mean of a series of number and used to describe about the data through mean. Same with median and mode. Okay, and with dispersion, what is dispersion? Dispersion, which means how far spread the data really is. Okay, like earlier you were describing by mean, like out of 10 numbers, middle number will be mean. Okay, and dispersion means how far the data has been spread. For that we use variance, like how far the value given value is from the mean. Okay, similarly standard deviation and range, like what is the range of the numbers that we are dealing with. And relationships, so relationship basically means we used to calculate the correlation between the different attributes of a data set. For example, if I mm, uh, calculate like whether a person has a heart disease or not, so I would require his or her cholesterol or age, and then what is the correlation between cholesterol and heart disease and age with heart disease. Okay, so for that we used to calculate using correlation. Okay, you will all see that in the code. Okay, so these are the main functions for statistics in Pandas. You have already learned about those in the previous lecture. And these are mean, median, mode, describe, and correlation. I think correlation will be is new this time. Other than this mean, median, mode, and describe, we have already learned about them in the previous lecture. Still, we will see them in the code. So let's go to code. Here, I have a small data set using this heart CSV, which basically calculates like whether the person has a heart disease or not. Okay, so I've taken these columns from that data set, as you can see here, and we will one by one use all these stats pandas functions to see what the result do we get. Okay, so first of all, df dot mean. For df, we will take one column. For example, let's just take age, and we will try to calculate the mean of that. Okay, so what is the mean of age, which means what is the average age of a person in this data set? Let's just print. Okay, so as you can see from the result, we got 53.51. It means the average age of the person in this data set is 53. Okay, so that's how you calculate mean. Similarly, you can calculate for all these columns. Okay, and similarly, we can also calculate. I'm taking age only. You can, when you try to practice even other data, you can either take the entire data set or uh, entire column. Just keep one thing in mind that all the if you like apply entire data set, just give it dot df dot mean, then all the values should be numerical. Otherwise, it will give an error. For example, if I calculate uh, average of these values, I will get an error in chest pain type because it is not a numerical value. Okay. So first of all, either I have to cut off that column or I have to encode that column. Encoding, I think you will learn that in the future lectures. Okay. So let's get back to the median. 54. Okay. So which means is that if I arrange all these value of the age, let me show it to you. Age. Okay. Keyboard error. Yeah, see. If I arrange all these value in an ascending order and then pick out the middle value, that would be 54. Okay. And similarly, if we go to mode, uh, print df dot mode. Mode is basically a most repeated value in a data set. Okay. Okay. So as you can see, 54 is the most repeated value here. Okay. Mode means that which value is the most repeated one. If I give you a list of number and I put number 6 there 3 times, then that means 6 will be the mode of that uh, data. Okay. And since we are done with mean, median, mode, I will go with df dot describe. Let's say I was already taking df. Let's just take df. Okay. Okay. See. Now describe what gives you a statistical summary of a data set according to the column. See here what this does is you won't find uh, these chest pin types, sex, or all these string based column because it doesn't have any numerical value. So uh, the describe function already removed those. So here you will get the count, like what is the count in the age column, what are the number of elements, okay, and their mean, their standard deviation mean, percentile, both interquartile and a quarter quantile, okay, and what is the max value there, okay. So the describe is used to get the statistical summary of a data set, okay, and let's go back. Okay, any doubt up till now? I guess not. Okay. Now last function was core. Okay. So df dot core, which means that you have to give a correlation between uh, different columns, like how much it can contribute. Okay. So for that, I will go with df dot one instead because if I use df, I will get error because you have to first encode these columns. Okay. So I've already created a small data set out of it by taking the numerical columns. Okay. As you can see there, you have age. Since so basically what you will get this correlation uh, relation relation between each and every column with itself as well as with other column. Okay, so let me first give you some background, then we will get back into it. Okay. Mean, median, correlation. Okay, yeah. So correlation measures the relationship and strength between two variables. As you can see in the code, that we are calculating the relationship between these variables by putting it in a numerical value. Okay. So as you can see, there will be like age has relationship with age as equals to 1. And with testing BP, you will have 0.25. Cholesterol is in minus. Okay, so what does this signify? Okay, let's see here. Okay, so it has a range between -1 to 1. Okay, which means if the value is greater than 0, until 1, it will have a strong positive correlation. Okay, that means the columns are strongly correlated with each other. Okay, and if it has zero value, it means value comes to be zero. That means there is no correlation between. That means these values have no relation between whatsoever. And if I get a value between 0 and -1, then it will have strong negative correlation, which means, let's say, if I let me show it in the table. Suppose let's just take a two columns here, age and cholesterol. Okay, as you can see, this is the value of their correlation, minus 0.095282, which means what happens is, if I increase the age, then cholesterol will decrease. Okay, that means they have a negative correlation between them. And with resting BP, age has a positive correlation with it, which means if I increase age, the resting BP will also increase. Okay, so that what means strong positive correlation and negative correlation. In the strong positive correlation, the value will be +1, and every column with itself have a +1 positive relationship. Okay, and in the -1 will be strong negative correlation, which means that the if the one column's value increase, then the column value will be decreasing. Okay, so where this it please, what is the practical applicability of this in a real world? Okay, so it's using finance, sale forecasting, healthcare analysis, and academic performance analysis. Okay, so where this is the where it is used. As you can see, there will be lots of correlation between, like, how is the stock performing when the government announced new rules. Okay, so that's how correlation can help in financing and the sales forecasting. Like in the winter, the sales will increase or decrease according to previous pattern. So similarly, that's how we calculate the relationship between two variables. Okay, now we go back. Yeah. So as you can already seen, like how do we calculate mean of a variable? Sorry, mean of values. And what does the formula of the mean? Okay, it is basically a sum of all the values divided by their count. Okay, if I give you 10 values till 1 to 10, and I want you to calculate the average. So basically, what you will do, like you will get the sum of all these values and divide it by the number of values. How many values are there? So as we have already seen, like here, what it did, like take all the ages and then created a sum of them and then divided with the number of values are there in this column. Okay, so that's how mean is calculated, as you can see in the example. Okay, so it's very, like, it's helpful to calculate the overall trends and performance metrics, like uh, where is the data is going or what is the average value. For example, you have some social media data of some person, of number of persons, and you need to want, like, what kind of product that can we sell them to them. So you will calculate to find these trends and performance metrics using mean, median, mode, all these descriptive analytics, so that you can get the various insights and then curate the product according to that. Okay. Similarly, with median calculates the middle value of the entire data set, as you can see in this graph. Okay, so yeah, and the mode means most frequent value, which means that in the entire data set, which is the value that is repeated most of the time. Okay, so why important? Okay, so, like, median, what it does is it avoids influence of outliers. What happens is, like, suppose I give you 10 values and the values are 1 till 9 and the 10th value is 100. Okay. So 100 is the outlier in this data. And what the and when it comes to outlier, the value mean gets shifted towards the outlier, because if you calculate the entire mean using these values, you will get the like mean. and the average value will be much higher. Since the 100 is the outlier compared to first 9 values. Okay, and mode. So if you don't want your data to be influenced by a single outlying value, you you should prefer median over mean. Okay, and similarly, mode helps in detecting common categories and values. For example, like if you have some kind of data, okay, and there's some lots of uh, values that are keep on repeating. So due to which you have a lots of computational overhead, okay, which means like your resources are go- these by calculating these values, the resources are getting thin in a very short amount of time. So there, mode can help you like detecting the common categories and values, and as to how can we then process the data. Okay, now just let me go to the. Let me check my mic. I think yeah. Okay, my mic is yeah. So we came back to correlation as I already explained it to you earlier. Like how why do we need correlation and how does correlation work here, and what is the well value significance of the value that we get in the correlation. So just to repeat in in this here, as you can see here, okay, as you can see there are lots of value here, which means the positive values are in a positive relationship. For example, age and resting BP are in positive correlation, which means if the age increases, resting BP will also increase. Okay, and age and cholesterol are in negative. Okay, which means if age increases, the cholesterol will decrease as is shown on the data. Okay, these values are calculated according to the data. Okay, now uh, we can also like uh, this get this correlation in a visualization form. Okay, so for that we import some library called Seaborn, which is a library used for visualizing data. Okay, creating graphs and all that. You will learn about it in a future lecture. Here you can just see one example. For example, Seaborn as SNS. Okay, I don't know why it's taking a lot of time in running. Okay, so in the meanwhile we write the code. Okay, SNS.heat map, and here we will give df.core as a argument and anode. Anode means that we will like show you the we will get these column names in the visualization also. Okay, and we have the CMap will be cool one. Okay, there are weird type of CMap, which means I will show you here CMap. Yeah, the mapping from data values to color space if not provided. Okay, so which means that it is a color mapping. Okay, it is a default or CMap. You can use cool warm. Basically, it's a type of uh, color mapping which is mostly preferred because it generally gives the best result. Okay. Okay, let's see. Okay, let me. Okay, DF1 here first of all. Since okay, same error. Let me check why. See, okay here. So this is a pictorial representation of the correlation. As you can see here, we also have these this type of bar which showing like how values color according to the values. And as you can see in the middle, this diagonalities is here it is 1, okay, which and it signifies like the res- relation column with itself, okay. For example, here age 1 is in the rel- positive correlation with age, okay, with itself. Similarly for all these columns, okay. And you can also see like wherever the value is positive, strongly positive, you will get the shade toward red, or mildly positive, you will be getting shades towards blue, and very, if you have uh, negative correlation, you will get a dark blue. For example, here you can see with heart disease, in the last heart disease with the max HR. These are strongly negative correlated, which means if max HR values increases, the heart disease value will decrease. Okay, so that's how you can also use this visualization in your project. Like if you want to be, because understand by visualizing data, you can easily able to understand it. Okay, now, so what have we learned so far? Like how to compute a descriptive statistics with pandas, and what does these statistics mean, and how does the correlation helps identify the relationships, okay, and how to summarize and interpret data, which means how to get the insights using these uh, data set, using these descriptive analytics, okay. One more tip, uh, as you can see here, by in the machine learning, when we calculate, when we try to find out like which columns do we need for the prediction for training of data, we take uh, data which is in the, like which are not too correlate strongly correlated with each other, either negative or positive, okay. So as you can see, the age is okay, yeah. So let me rephrase it. We do not take the columns, or we take only one of the columns which is strongly positive correlated with each other, okay. If you, for example, here age is most strongly correlated in positive with heart disease, okay. Sorry, heart disease is a resulted column. Let's just say old peak, okay. Age is strongly related with old peak. So by for the training of data, we would need only one of these columns, okay. So keep that in mind while when we try to train the model, we will take only one of the strongly positive correlated, not negatively, only strongly positive correlated function. Okay, so that's it. That's the end of the lecture. And for this, for today's lecture, your assignment will be like calculate the uh, mean, median, mode, standard deviation, and minimum and maximum values, as we saw in the uh, as we saw in the describe function here. This one. Okay, so you have to take a small data set of yourself, of your choice, and calculate this. You can just calculate by using this function. Okay, and create a correlation matrix of of the data set of you're choosing. Like this is a correlation matrix. Okay, these two df core using core function. This, and write 5 insights based on this set. Like what are the 5 findings that you receive? For example, here one of the findings that age, the age column is strongly correlated with resting blood point, resting BP. Okay, so you can write these type of findings also, and that is your exam assignment for today. Okay, then that's the end. Any doubts?
No, sir.
Okay, then thank you.
Thank you.